So hi, hello, welcome back to my YouTube channel. We are learning embedded system for 30 days and this is day 5. So without any further delay, let's get started with the topics of day 5. We are in day 5 and the topics we are going to learn are what are interrupts, why we use interrupts versus polling, basic interrupt flow, how interrupts works in Arduino. So the first topic, interrupt. So what is an interrupt? It is a signal that temporarily stops the current program. So MCU can handle an urgent task. So let's assume a situation of real life. So assume a situation where you are waiting for your call from a friend. You would be frequently checking out for a call. You would be taking out your mobile and checking for a call. That's quite inefficient and we might be wasting time. So there's an alternative. When the phone rings, we can check it out and answer the call. So that's in technical terms could be called as an interrupt. And the situation where we are frequently checking our mobile for a call notification would be called as polling. So which is an repeated task. We were checking our mobile frequently for a notification or a call is polling, and the efficient way was answering the mobile when it was sending a notification. So let us understand the workflow inside a microcontroller unit. So normal flow would be going like the MCU reads the sensor data and calculates the data and update it as per the consequences. But when an event occurs, let's say the button is pressed, it completes the timer and the data would be received at the final stage. So what would be the reaction of the MCU microcontroller unit? It temporarily starts the main program for an instance. It would run the specific function, the ISR, interrupt service routine, and complete the interrupt work and return back to the main page where the actual program would be learning. Let's get with an practical example, right? Assume you are designing an alarm. The main task was detecting temperature. In case of an emergency, let's assume there was a fire accident. When someone press the button, it need to give a buzzer. That's an alarm. If there was no interrupt, it would work inefficiently. It would be running or detecting the temperature in the step by step. When a button is pressed, it would be very long and the emergency case would be failed due to the inefficiency. This is where the interrupt would be playing a major role. So interrupts mainly work on the priority. There could be priority of higher priorities and lower priorities. The higher priority task would be completed first and the lower would be done next. When an interrupt service routine, the emergency function of an interrupt runs, the main program would be paused and the interrupts may wait for completing the task which is an emergency. So that's for part 1 of learning embedded system on day 5. And here comes the part 2 of day 5. Interrupt triggering. Interrupt occurs when a microcontroller must know the triggering pattern. Interrupts are the function which pauses the main function. So we need to have the knowledge when we need to trigger the interrupt. So there are some types of triggering. Let's get into it. There's rise edge triggering, falling edge triggering, and change triggering, and level triggering. So rise edge triggering. When the system is currently at low input and want to get into high input, let's say 0 was the default stage and we are trying to go to an high stage of 5 volts. This is rising stage and it would be called rising edge triggering, which is observed in the pull down resistor which we have discussed earlier. An example of it would be a sensor. A sensor would detect from a no stage to some movement or some value. Falling edge triggering, where the default stage would be high and the system need to convert it to the low stage, which we have observed in the pull-up resistor. Assume a button, when it's in the on stage we need to off it. And change triggering. Change triggering is a combination of first and second, that's rise edge triggering and falling edge triggering. It's both when the default is high and the where default is low. Low need to be converted to high and the high need to convert it to be low, which is observed in encoder. So level triggering, it depends on either it's low or high, where we need to convert from low to high or high to low, which is an advanced control model. That's it for part 2. And here comes the final part. Here we are going to learn button bouncing and button debouncing. So what is bouncing? What we understand from here, the button bouncing concept is generally the state is high and it changes to, sorry, my bad, that's low and it changes to high, or from high it changes to low. What actually happens is when a button is pressed, metal contacts inside the button would hit each other and this creates a vibration for milliseconds, where the system goes into on and off condition for multiple times, is called button bouncing. So why it's dangerous? MCU thinks that button is pressed for multiple times, the interrupts would be triggered for multiple times. The system might give wrong outputs and the wrong behavior. So the practical issues with button bounce are motor would start and stop repeatedly, counter gives wrong values, IoT behaves randomly, are some of the drawbacks of button bouncing. and button debounce, which would overcome these issues. Here it generally removes unwanted rapid changes, making button press appear single time. Here it would be repeated for multiple times, right? Here it makes as one, like on and off. What is the present state? There are two types of debouncing: hardware debouncing and software debouncing. In hardware debouncing, we overcome this by using the physical components, resistor and capacitor. In software debouncing, the MCU ignores extra values for the first time after button press. When once it's been detected on and off, it verifies for the second, and it generally sticks with the first trigger. So software debouncing flow would be like when a button is pressed, it waits and checks and it accepts the interrupt, and here comes the end of day 5. So we have covered why interrupts are used, what is interrupt and polling, and basic interrupt flow. So that's it for the video. Let's meet in day 6 with new content. Till then, keep learning.